Okay, welcome to my talk about versioning your PowerShell modules. So first of all, big thanks and shout out to our sponsors. Without them, this conference wouldn't be possible. Without the attendees, it wouldn't be possible either. Okay, who am I? I'm Emrys. I'm a team lead from a small team called Deployment and Automation at a company called Mendavis. I've now been a whopping 19 years in the IT business. And after playing around with our lovely VB script, I started using PowerShell 15 years ago and I've never looked back. So what we're going to talk about today. So we're just generally going to talk about versioning, what's versioning, different kind of versioning schemes, just get a broad overview what that is. Then we're going to have a look at semantic versioning, which is a specific versioning scheme. Then we'll have a look in how to manually and semi-manually version our PowerShell modules, and at the end we're going to have a look at a tool called Git version, which will help that process. So what is this talk about? Obviously, versioning our PowerShell modules. What I'm not going to talk about is module templating, build pipelines, so there are other talks for that, and you can get that figured out somewhere else. Okay, what is versioning? Well, versioning is assigning unique identifiers or numbers to different versions of your software, documents, and products. It helps us track updates, changes, and revisions over time. It helps us understand the evolution of a product, in this case, PowerShell modules. It will help us manage compatibility between different versions. So if we have a required module, we might want to say, I need this specific, difficult word, versions in our module. And logically, but each version represents a specific time in your development. So one version is one commit, is one set of code. So what versioning schemes do we know in general? So we got sequential numbering, like version 1, version 2. I think we all can remember that when we were in school, in uni, homework, version 1, version 2, version 3. Great fun. I love that. Then quite common, you also see date-based versioning, which is like year, month, day. One module that does it is Adam Discroll's PowerShell Pro Tools. That has a date-based versioning scheme. Then we all know internal build numbers, like in Windows. We all know that Windows has a cryptic build number to tell us which version we're on. Then we've got versioning schemes like major, minor versioning, like a 2-digit versioning scheme. And then we've got semantic versioning. So what's semantic versioning? Semantic versioning is a widely adopted versioning scheme in many programming languages. So that has nothing to do with PowerShell. Java users do it. C# programmers use it. Lots of people do it. It helps users and developers predict the impact of software releases. So this is great. I can look at a semantic version and I can tell you my code's going to break or not going to break because it gives us so much information. And it consists of 3 numbers: major, minor, patch. So what does a major part mean? So the major part is like you always increment the major version if you have a breaking change. It tells the user something in your API is going to change and your scripts based on your modules might break. So for example, if we're talking in PowerShell, you change the output of a function. That might break someone's script using your module. Or we change the properties a function uses and make it mandatory. So something changes that breaks or that could break existing code running against your module. Then we've got the minor version. That's the 2nd digit. That tells us that someone added some kind of functionality to our module. And it must be backwards compatible. So that's important. So if the minor version is incremented, the user knows his scripts will still work. Just functionality has been added to that module, for example. So backwards compatibility is super important. And when we're talking PowerShell, that could be we added a new function to our module, or we added a non-mandatory function to a non-mandatory parameter to a function that is not breaking. And last but not least is the 3rd digit, which is the patch version. So patch version basically tells the user something has been fixed, some bug has been fixed in the code. and it's still backwards compatible. So if you make changes, always make sure it's compatible with existing scripts. Semantic versioning also offers you optional parts of your version number. Most well known is a pre-release tag. In this case, it's the alpha 1. That indicates that the version is not final. So if you put out a module with a pre-release tag, all the users will know this is not final. This may break, there might be bugs, but it can offer you just the opportunity to test some scripts or modules. The pre-release identifier comes directly after patch and always begins with a hyphen or a minus. Pre-release versions, logically, precede the final stable release. So we got alpha 1, so we got 1.00, alpha 1, alpha 2, RC, whatever. And then comes the actual release, which will be 1.00. So the 1.00 is always newer than a version with a pre-release tag. And the next thing is we have build metadata. So this can be just additional metadata out of your build pipeline. It could be a commit hash or any other information you want to provide when building a module or any kind of software. It comes directly after patch or pre-release and always begins with a plus. So that's how you can identify metadata tag. And the metadata tag has got no precedence over other versions, so it's not sorted in any way. And like pre-release, which I didn't mention, it can consist out of digits, characters, minuses, dots, and whatever. So versioning PowerShell, now we're going to look how it works in PowerShell. So in PowerShell, we can use different schemes. We can just go for a two-digit versioning scheme like major, minor. We can go and use a 3-digit scheme like major, minor, patch. But we could also use 4 digits, which would be major, minor, patch, or build. However, if we want to use a pre-release tag, it must be 3 digits. So if you're considering using pre-release tags, 3 digits. I still use PowerShell get. I don't use PowerShell resource get yet currently because there are some issues with our repository. But if you use PowerShell get, you cannot have dots or minuses in your pre-release tag. And there's no metadata support for PowerShell get. Okay, that's it for the slides. Let's get into some demos. Okay, so how can we version our module? So the basic and the easiest way is to edit our PSD1 file. So I just scroll all the way up to the top, and we should find our module version. So if I want to update it, I can just update it to 0.11. And then I can just publish my module to my repository. So I'm currently running a local repository, but this could be the PS gallery or your internal repository in your company. So we can publish it. It is taking a long time. Now, and then we can check the version, and we can see we just published our version 0.11 in our personal gallery or our repository. So great, easy, simple, manually editing. So the next thing we can do is we can also create a new version with a pre-release tag, also in a PSD1 file. So we'll just create a new version, 0.12, and then we have to scroll a long way, which is going to be difficult with this font size. We go down to private data. Yeah, here we've got the private data tag, PS data, and we'll find a pre-release property, and we can just uncomment it, and we can just add alpha 01, and then we can just publish it again, and then we can have a look at it. Okay, so we can't see it. Why can't we see it? We can't see it because if we look for modules, it will only show us the stable versions without pre-release tag. So if I want to see pre-release tags in the PS gallery or in your own repository, you just have to add the allow pre-release property, and then we'll see there's our 0.12. So if a user can go and grab it with the knowledge, it's not final. So who likes editing config files manually? Hey! Yeah. I thought you would, Jakob. Okay, so if we want to do it in a more, let's say, PowerShell-y way, we can just use the update module manifest commandlet. We just point it to our PSD file, and we just add the module version. So if we execute that, we can go back into our PSD file, and we'll see two things. Number one, we're on version 0.20. And if we scroll back down to our pre-release tag, it's gone. Because update module manifest, if you give it a version, it will set the pre-release tag. It will comment that out. Everyone okay? So it comment out the pre-release tag for you, and you don't have to think about it. So that's just an easy way to update your module manifest. We can publish it. And as soon as it's published, we'll go into the gallery. This time we'll also add the allow all versions. And then we can just see all the versions in our repository, pre-release and final versions. So now we obviously released the version 0.2.0. Now we want to create a new version. This time we'll just add the pre-release tag to alpha 1. I can show you. It didn't work. Great. Now, here we got it. It took the comment away, put in alpha 1, and the version is also updated to the version 0.2.1. I think you'll just believe me on that. We can publish that again. And we can So, did it get published? There we are. Published. Perfect. That was simple. Now you are developing your module. You're coming to a stage where you say, oh, it's not alpha anymore. It's a RC1, a release candidate. So we can do that. We'll just update our module manifest once again with the pre-release tag RC. We will publish that. And we'll just execute the find module. And we can see we have our alpha version and our newer version, which is RC01, which is newer. Perfect. So we continue to fix some bugs, do some work on the module, and now we say, in PowerShell I often see pre-release as a tag. I want to use pre-release. Okay, so we'll do that. We'll update our module manifest to pre-release, and then we publish that. And we find dreaded red text. So basically what's saying here is the preview version is older than a version which is already in our repository. So publish module will actually check the version. And the reason for this is RC begins with an R and R comes after P. So pre-release tags are just alphabetically sorted. You just have to know that. However, if you do want to publish an older version, you can just add the force flag. And then it gets published to our repository. And if I check the versions, we just published the preview 01, but it precedes the RC2 due to the semantic versioning rules. So just keep that in mind. You're not completely free, and it's not the time when you publish something. It's alphabetically sorted. Okay. So I'll just create a new version, 0.15. And we'll update that. And again, 0.1.5 is older than 0.2. We can't push it. We could add force to push it. However, if you are already using PS resource get, doesn't give a damn. You can just publish any version. So you got no version checking with a new PS resource get. So just keep that in mind. And if we so there we can see our newly published version, however it's older. Okay. Now let's say you want to publish a version twice. So we're having the version 0.3.0. We can publish that. Can push it to our repository, and then we can do find module. We will find our new version. Perfect. Now we want to release it again. And we get red text again. So here it doesn't matter. I can add the force parameter. I cannot override it. So if something's published, it's published. And you shouldn't change it. Should never change it. So this is fun. Now we know how to version our modules. We can all go home. But the problem is, who likes doing something manually? So basically, writing a code, you want to push it to your Git repository, and if you forget to version your module, it will break your build pipeline, and it can't be released. So there are a few strategies and ways of automatically versioning your module versions in code in your build pipeline. And what we want to do is we want to basically know every time I push something to my Git repository, have a commit, I want my build pipeline to kick in, build a module, and create a unique version that gets published to my gallery. And for this, I use this approach, or sometimes use this approach called incremental versioning. So when we build our PowerShell modules, the majority of our modules are like feature complete as soon as you start developing your module. So I've got tons of modules consisting of 1, 2, 3, maybe 5 functions, and I start developing them, and after a week or two, whatever, they basically feature complete. They will never change. They only get minor bug fixes, and this is where this incremental versioning could come in handy. And this is nothing I dreamt of and thought, I've got something cool to show you. This is actually code I've also seen in lots of GitHub repositories. I know that MVPs who are attending this conference use exactly this approach. So basically, what am I doing? I'm just going out to my PowerShell gallery and just going to grab the newest version of my module. Just get it from my repository, grab the newest version. And then I'm just saying, if this version is lower than 1.00, the new version will be 1.00. Else, if it's higher than 1.0, I'll just take the same major version, I'll take the same minor version, and I'll just increment the patch version. As I said, this is an absolute viable choice if you've got a small module that doesn't change. Like Pester. Tiny. Okay, and after I got the new version, I'll just update my module manifest and push it to my repository. Okay, and if I execute this code, current version is 0.30, new version 1.0. I do some changes, push it to my repository, my build pipeline kicks in, and it just calculates a new version, and I keep going over and over again. So 1.1, 1.2, 1.02, and so on. Great, this will work for your small projects. Now, we also have bigger projects with more functions where a module has a certain life cycle and will get new functionality. There's a scheme I've adopted. I call hybrid versioning. Once again, this is a bit more flexible. It's not 100% automatic, but I can be sure that my build runs through. So what am I doing here? I'm going to get the current version out of my PSD file with import PowerShell data file. I can just read out the PSD file and I'll just get the module version. Then I'm saying I want to manage my major and minor version manually because I know when I'm adding a feature, I know when I'm doing a breaking change, so I'll maintain them manually. And for the patch version, I just need a unique version. I don't really care. And then I just go out and get my git commit count. So how many counts have I got on my git? How many git commits have I got? And I'll just take that as a patch version. And then I'll just take that so I can control major, minor. I don't have to think about patch. And I always know that every commit creates a unique version. So I can just execute that. So I get now the 1.020 because I've got 20 commits on this repository. And if I do, wait a minute, got it here somewhere. Git. So if I just do any old git commit, and I run it again. What the? Wait a minute. Shit. Wrong code. Let me fix that quickly. Okay. So. Okay, so it's already been published. It exists in my repository, so the demo gods are not good to me.
No, it's good.
Okay. But you would believe me, it would publish the right version. Okay. Demo gods are not good to me today. Okay. So that's our two approaches how we can use a bit of PowerShell script to version your modules and be sure that it can be pushed to a gallery and has a unique number. But there's other ways as well. Great. Now things are going wrong. Okay. So, Git version. Git version is a tool that helps us the heavy lifting of versioning. So Git version generates semantic version numbers based on your Git history. So this tool goes and looks at your Git history and says, oh, I know what version you are. Sounds like black magic to me, but it really works. It's used for stamping version numbers on artifacts produced during builds. So in our case, PowerShell modules, but it could be any other software project. It's highly configurable. So you can make it do what you want, but configurable also means difficult, and it supports many Git branching strategies. So before we start using Git version, we have to talk about Git branching strategies. And out of the box, Git version uses Git flow, and Git flow is a highly debated Git strategy under developers, and I would say it's made for larger developer teams who have long-living products, and they do backpatching and other crazy shit, and have feature branches that live for a couple of weeks, which they only push to production every 3-4 months. And it's pretty complicated. So you start off your main branch, you always branch off to your develop branch because all the development is started off the develop branch. You create a feature branch, you push the feature branch and back into the develop branch. If you think that is cool, then you create a release branch. And that's just way too complicated for someone like me. It just is the way it is. So the approach I take is like, and I've talked to other people, is like a trunk-based development. So what I want to do in PowerShell, I want to do my code changes and ship it as soon as I can into production. If I create new features, when I create a new feature, I know the feature branches normally last 2 hours, 5 hours, maybe max a couple of days. So I've got very short developing intervals, and I want to keep pushing it. So what I would like to do is I would like to start off with a version 1.00, and then someone comes, hey, you've got a typo in your documentation. So I don't want to go start off creating a new branch just to fix a typo. I just want to fix it in my main branch, and I want Git version to say, I know what version you are. You are the version 1.01. Okay, someone else comes and says, hey, you messed up. There's a bug in that function. Can you fix it? And I say, I can fix it. It's a bit more complicated. So I do decide to create a new patch branch. So basically, I want to create a new branch called patch / my branch name. And I want Git version to know, you are version 1.02 alpha 1. And I want to push that. I want to build it, and it gets pushed to my repository, and my colleagues can have it, verify it, look at it. If everything's okay, I might create a PR, or I just merge back into my master. And what version should my master have? Or my main branch? Exactly. Without a pre-release tag. Okay, great. That will be really cool. Next, I want to add a feature, create a new feature branch. And because I call the branch feature, it should become the version 1.10 alpha 001. I work on it, get the 1.10 alpha 2, and when I merge it into my main branch, obviously it becomes a stable version 1.10. Okay, another example. I create a new feature branch that obviously is 1.2 alpha 001. And now I notice I've got a breaking change. I'm changing something that will break backwards compatibility. And now I have to increment the major version. So wouldn't it be so cool that I do the breaking change, and in my commit message, I add somewhere in my commit message, I add something like whatever I want, like in this case, plus semver major. Like I'm just telling in my Git repository, in my commit message, there's a breaking change, and it gets automatically bumped up to version 2.00 alpha 1. And when I merge it back, I've got my final version 2.00. So that is what I want to achieve. So we get back to the demo and hope that things work. So first of all, I will just initialize my Git repository with an initial commit. So on my machine here, I've got Git version installed. You can download it from the Git version website. You can use Chocolatey, Winget, or .NET Global Tools you can use as well to get your Git version. And when you execute it, we get this huge JSON file with tons of information about our version. So we get major, minor, patch. We got no pre-release tag. We've got some build metadata and tells us what branch we're on, and all this information, which is pretty cool already. Let's scroll down here. And so what you can do is you can then take the JSON and take it apart, or you can use Git version show variable NuGet version v2, which is a bit more handy. And then we'll just see it's a version 0.10. So we're starting off at the version 0.10 because Git version always starts at that version number. And now I'm working, create a commit, and I'm going to look at my version again. And I say, damn it, I'm still on the version 0.10, even though I did a commit. And that is because out of the box, Git version follows Git flow. And I have got no Git config in here yet, but there is still a Git config, which I can use Git version /show config to show me the config file. And this is actually the whole config. It's quite long. So there's actually always a configuration behind Git version, and this follows Git flow. So if I want to change that, I have to create my own Git version config and tell him what to do. And that's exactly what we're going to do now. So I've got something prepared, and I got my Git version config. And we'll quickly touch the config file. So default mode is continuous delivery. I've set the mode to mainline. That's what supports trunk-based development. I also got here in the config my git commit messages, which will help us version or how to bump a version. So basically, I'm saying here, major version bump message, if it finds with regex plus semver breaking or major, it would bump the major version. And we got the equivalent for minor and patch. Then I have to set up my branches. So I'm just setting up my main branch, and I'm saying my main branch doesn't have a tag. And any change on my main branch, my patch number should be incremented. So I can fix a bug directly on main, that will be updated. And then I'm just telling him with a regex command, what are my main branches allowed to be called? So some people still use master, some people use main, and then it'll identify their main branch. And I'm just saying it's in mainline mode. Next, I'm defining my hotfix branch. And here I'm just saying my hotfix branch will automatically get the pre-release tag alpha. And everything, as soon as I create this branch, it will be incremented by patch. And their branch name either starts with hotfix / something or with patch something. That's how I can identify. Then I've got the same for the feature, alpha tag again. This time it will increment minor. And my branch has to begin with feature / whatever name I want to call it. And I've got, of course, settings for my pull requests. So when I'm in my build pipeline, I've got a pull request. So when I create a pull request, it will have the tag preview, and it will inherit the version from its source branches, and source branches allowed to be feature or hotfix branches. Now let's see this in action. Okay. So first of all, we want a starting point. I don't want to start with a version 0.1.0. I want to start off at the version 1.00. And for that, I just set a git tag. And then git version, when it starts calculating the version, will look, is there a git tag somewhere? And we'll look for the last git tag and start off calculating from that point in time. So if I just go git version, show variable, I can see. Can you all see that? It's a version 1.00. So this is our starting point. I'll just change my code, create a commit, look at my version. Hooray! Success! We got 1.01. We got out for a good start. Okay. I might want to create another one, and doesn't sound good. And there we got the version 1.02. So this is working. Okay. Now I'm going to have to do my patch. So I'm going to patch my software, going to create a new branch called patch, new patch. Now let's look at this new branch. I'm in that branch, and that's been incremented by 1, but has additionally become, because I'm on the patch branch, it automatically is alpha 000. I do another commit. Check the version. Yes, still the same version, but a different pre-release tag, alpha 001. Now, of course, I switch back to main. Check the version. Still on 102. And now I'm going to merge my patch branch into my master branch. And now one thing is important. You have to turn off fast forward. Otherwise, otherwise your Git branch will be squashed in, and Git version can't see the branch anymore and then can't calculate it properly. So you have to make sure no FF is off. I use Bitbucket as my Git repo. That's as a default behavior with a merge request. I don't know how it is in GitHub. Does anyone know?
Merge is the default, but you can set policy to anything. For example, in most of our repos, we use squash. So
yeah.
The opposite of what...
Yeah, this wouldn't work exactly. Yeah. But it comes down to your configuration. You can get a Git version to do what you want then. So... and now I merged it, and now we can check we got the version 1.03. Now we go off and create a new feature branch of our main branch. So we're going to call it feature, new feature. Check the version, 1.1, and I haven't done anything. Git version's doing everything for me. just do another commit, check the version. It's gone from alpha 000 to alpha 001, but it maintained the actual version. And now, once again, I can go back to main. I can merge it, and then my main branch is on the version 1.1. Cool, absolutely brilliant. Now we're creating a new feature, as I told you, create a new feature called new feature 2. We got the version 1.2, alpha 00. Do a commit, alpha gets incremented by 1. And now we're doing our breaking change. So we had something, I realized this is a breaking change. Then I just type in my message, and somewhere in that message, I just add plus semver major. And as you can expect, it bumped our version automatically to 2.00 alpha 002. So now, same game as always, we can switch back to our main. There I'm still on the old version 101.10. That's what. I can merge it. And then we've got the final version of a 2.00. So that's one way you can use Git version. So if you start using it, this is a starting point, not more. And then you can just find out what configuration works for you. So this is my configuration. This works in my environment. So what's my conclusion? Definitely use semantic versioning. It tells your users what to expect. It will tell the users if the scripts are backwards compatible or not. When you versioning your PowerShell modules, you don't have to use Git version. You don't have to go fancy. You can use a simpler approach. Use what works for you. And this sounds a bit silly, but take versioning seriously, but not too seriously. What I mean is, make sure you have a good major version and a good minor version. But to be honest, patch version doesn't really matter as long as it gets incremented or is higher than the other version. And that's my conclusion. And now I'm open for questions. If there are any questions. Oh, yeah, of course. Okay. No, Jakob, please.
I don't know if I got it totally correctly, but every time you merge a feature branch into the main, you are incrementing the minor version, right?
No, if I'm merging, so my feature branch is, let's say, 1.50 as an example, and I merge alpha 001 because it's a feature branch. In my example, will always have a pre-release tag, and if I merge it into main, it loses that pre-release tag. So out of that version 1.50 alpha 1 becomes in main 1.50.
Then if I have another feature after that, will it become 160?
Yes.
So do you release every time you merge a feature into main?
Yes, that's how we work. Okay. So basically every feature is a new release, gets pushed into main, and we use it. So we want to develop quickly and push everything into production as soon as possible. That's our approach. That might not be your approach. And it definitely depends on the size of the project you're working on the module version. So the smaller the module is, the faster we want to push it. So if you have a big complex module, we'll have more testing and we'll just work slower. Yeah.
Okay, thank you.
I have a question. What if you have multiple feature branches at the same time? Does it really depends on the pushback to main, or because like we have multiple developers, and one will start his local feature 01, and I will start feature X. How does that?
Okay, so the question was what happens if you have two feature branches at the same time? So when you're working locally, the local version might differ because you don't know his state. But if you keep pushing to the repository and keep rebasing your code, it will calculate correctly. But as I said, it could happen that what you see locally on your command line, that version might differ to the version in your build pipeline. But what happens is the build pipeline knows the whole Git history and will calculate it right. You had a question? Okay. Any more questions?
Just curious. Do you also integrate the tagging once you do a release? Do you also add a tag for the release that you created?
So the question is if I add a Git tag to every release? No, I don't do that. So there's no need in my scenario. As I said, it's different if you're creating a module like Pester or DBA tools and it's open source, you want to have different Git versioning strategies and then you might work differently and need more careful when you're releasing something. It just depends on the size. So this is for this concept is for internal use or for small teams and small modules. That's what I would say. There was one question somewhere. Jakob?
When you said that it won't work with the squash, the merging of the commits to the main, like putting all of them into one, do you know about strategy that will work for it? I don't know if you experimented with this, maybe you have that.
So the question was, is there a strategy where the squash will work? I don't think so. If you want to version everything through the branch name, then it will, because that information is then lost and Git version can't see it anymore. But what you can do is, have we got some time? I've got something for you. I was playing around with different Git version configs and just. So this will be a different approach. So this approach, this Git config, is simpler, and what it does is it just increments patch every time, no matter what, if it's a feature branch, and will just rely on the commit messages the developer puts in. So you can purely go and say, if I've got a feature branch, I'll just add in my first commit plus Semver feature, and then it'll be incremented through that. So I won't go with the branch name, but I go with the commit messages, and that would work with a squash. Björn?
Not so much a question, but sort of important small note. If you want to use this in a pipeline, make sure to enable deep cloning on your repo.
Yeah, that's very correct. So the thing is, when using Git version has to have knowledge of your whole Git history. So you can't do in your build pipeline shallow cloning. You have to always have a full clone of your whole repo. Yeah, that's a good point. Very important. Yeah, I had that problem as well. Yes. You? Yeah, that's you.
I thought you were looking over me. Could you enforce, because I see that if you take that strategy where you rely on the commit message being Semver something,
yeah.
Could you enforce it in the policies that actual developers use it? Because that will break if you omit the Semver stuff, because Git version would still be confused if the commit message doesn't really contain what it's searching for.
So in this approach, if the developer, so that the question is, how can I enforce this kind of policy? So if a developer decides to just don't do it, it will just be incremented by patch. And if he wants it to be incremented by minor or major, he has to do that. But that is basically is a contract between the developers. What is our Git strategy? How are we going to work? It's just a basic contract when people work to. I wouldn't know how to enforce it. I don't know how you can enforce Git strategies in teams. I mean, programmatically, it's a verbal contract between the partners, how we work.
Thanks.
Then thank you for your time.